Hi, third graders. Today we're going to do lesson 9 of our maths module 4. And we're going to continue looking at area. Let's do a quick review. Here we have a rectangle. Each little square is a square meter. It says here. So what is the value of this side length? There's 2 squares, so it's 2 meters. What is the value of this side length? There's 1, 2, 3, 4 squares, so that's 4 meters. And write a multiplication sentence to represent the area of the rectangle. And we have 2 times 4 meters is 8 square meters, or 4 times 2 is 8 square meters. Okay, let's also do a quick review of the distributive property. In multiplication, we have 8 times 6. Let's say we don't know this multiplication. We can break apart the 8 in 5 plus 3. So we have 5 plus 3 times 6. And we break it apart. So 5 times 6 plus 3 times 6. 5 times 6 is 30, plus 3 times 6 is 18. There we go. 30 plus 18 is 48, which is our 8 times 6. 8 times 6 is 48. We'll see that this is useful when we're calculating the area of 2 rectangles, and then we push them together and add up the 2 separate areas. Okay, let's look at this problem. Mario plans to completely cover his 8-inch by 6-inch piece of cardboard with square-inch tiles. He has 42 square-inch tiles. How many more square-inch tiles does Mario need to cover the cardboard without any gaps or overlap? Explain your answer. So here's Mario's piece of cardboard, 8 by 6 inches. So how many tiles? First of all, I need to know if I'm covering it in square inch tiles, how many tiles will Mario need? We have to do 6 times 8, which is 48. Mario needs 48 square inch tiles to cover the cardboard, but he only has 42. And the question is, how many more will he need? So you can do 42 plus what is 48, or 48 minus, let's move this here, 48 minus 42, which is 6. Mario needs 6 more square inch tiles to cover the cardboard. Okay, let's look at this grid. How could we cut this centimeter grid to get 2 equal rectangles? Okay, so wait, let's move this here. Okay, so look at the centimeter grid. We need to cut it in half to get 2 equal rectangles. So I'm going to look at this side here and see how long this side is, how many squares there are along this side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I can cut it along this line here after 1, 2, 3, 4, 5 along this line here. And I will have 2 rectangles that are exactly the same. So we cut it in half. If we cut on the line between the 5th and 6th rows, we'll have 2 equal rectangles. So also along this, we can cut it in half along this line here. 1, 2, 3, 4, 5 along this line here, and we get 2 equal rectangles. Or we can fold it in half. Okay, so let's imagine that I fold it in half along this line and cut it so that I have 2, let me see, so that I have 2 identical rectangles. 1, 2, 3, 4, 5, there we go, like this. Okay, so this rectangle is exactly the same as the one below. And now imagine that you cut them and you put them side by side like this. Okay, so you cut them and Then you put them side by side, so you will have two rectangles that are exactly the same, with the short side that's 5 centimeters and the long side that is 10 centimeters. And there you go, and there's two. Write an equation to find the area of one of the rectangles. That will be 5 times 10, okay, which is 50. And write an equation to show the total area of the two rectangles. So since they're exactly the same, I have the area of one rectangle, which is 50. The total area for both rectangles will be 50 plus 50, which is 100 square centimeters. We're always talking about centimeters. Our unit was centimeters. Okay, imagine that we push these two rectangles together to make one big rectangle. Okay, remember we had our two rectangles and we put them together along the short side. So this side will be 5 and the long side will be 10 plus 10, which is 20 centimeters. Okay. Now it says find the total area of the longer rectangle. What will the total area of this big rectangle be? Of course, it'll be 5 times 20. And 20 is 2 tens, so 5 times 2 tens. That we can also write as 5 times 2 is 10, 10 tens. 10 tens is 100, so the area of the longer rectangle is 100 square centimeters. Always remember your square, when it's an area, it's square units. And our units were centimeters. Okay, this is a similar problem. We have two rectangles, except that these are not the same. Notice that the short side is 4 units, 4 square units, 1, 2, 3, 4 for both rectangles, but the long side is, in the first rectangles, it's 6 units, and we don't know if they're centimeters or inches. And the second rectangle, there's 7 units. So we already labeled the side length, so let's find the area of the first rectangle. We'll have to do 4 times 6, or 6 times 4, which is 24. That's the first rectangle. The second rectangle is 4 times 7, or 7 times 4, which is 28. So we have 24 square units for the first rectangle and 28 square units for the second rectangle. Let's imagine that we're putting these, like before, we're putting them together along the short side, along this side, to make one big rectangle where the short side is always 4 and the long side is 6 plus 7, which is 13. Okay, we have to calculate the area of this big rectangle. That would be 4 times 13. What can we do? We can also simply add 24 plus 28. So here it says, Rahima says the area of the new longer rectangle is 52 square units. Is she right? Yes, she's right, because 24 plus 28 is 52 square units. Okay, let's look at this last problem. Kira says that she can find the area of the long rectangle below by adding the areas of rectangles A and B. Is she right? Okay, look carefully. This is, okay, this is rectangle A. You see it? And see the dotted line, look at the dotted line is rectangle B, which is in gray. As you can see, there's an overlap. So rectangle B, there's an overlap between rectangle A and rectangle B. So Kira says she can find the area of the long rectangle by adding the areas of A and B. In this case, it is not true, because this longer rectangle is, the area of this longer rectangle is smaller. It's smaller than the sum of the areas of rectangle A and B. Okay, and that was lesson 9, module 4. You can now open the slides, and I think you can easily do them independently. These are the slides that you are going to do, including the exit ticket. Bye.